Okay, for this question, we're trying to investigate the volume of a rectangular box, and we notice that the corners are being cut out. This flat diagram here is like the net of our box. So the total length of cross would be 20 centimeters, and we've got two little cutouts here, which are each x centimeters long. So the first part of the question says find the length of the edge of the box, or the base of the box. So if we folded that up like this into our 3D box, what we're looking for is this base edge here, so this little tiny part there. So first part, we notice that all the way across would be 20 centimeters, and we have to take away two lots of x. So we could write L equals 20 minus 2x. The second part of the question is to then find the volume in terms of x. So for a rectangular prism like this, we know the volume will be the length times the width times the height. So our length is 20 minus 2x, and we notice that the other base there, it's a square, not a rectangle, so that is the same. So we're going to have two lots of that. So I'm going to square that bracket multiplied by the height, which when we fold the box up will just be x. So my formula is x times 20 minus 2x all squared. Part C is asking us to find the volume when x is 5. So we can use that same formula we just found, but when x equals 5. So we'd have 5 multiplied by 20 minus 2 lots of 5 all squared, which is 5 times 10 squared. So our volume would be 500 centimeters cubed. Now part D is asking what values of x will give us a volume of 500. And you might look at part C and go, well, I subbed in 5 for x and I got a volume of 500. So my answer is 5. That's only partly correct. So one of the answers is 5. And that's an important thing to notice, because if x can equal 5, that means that x minus 5 is going to be a linear factor of this expanded cubic. So we'll use that later on. First thing we need to do though is write out our whole volume formula and make it equal to 500. So our volume formula, which was x times 20 minus 2x all squared, and I'm going to make that equal to 500. And now I want to solve that for x. I'm going to have to expand the brackets. First, I can take out a common factor of 2 from 20 minus 2x. So I'd have this will become 4x, because I've got a squared bracket, so there's really two lots of those brackets there, so I'm taking 2 out of both of them, and I'll be left with 10 minus x equals 500 squared. So let's expand those brackets now. So I'd get 4x multiplied by, in brackets, 10 squared is 100. We have minus 20x plus x squared, and now I'm going to minus the 500 over and make this whole thing equal to 0. So then I can try and solve for x. Let's multiply through this 4x term, and I'm going to put my cubed term at the front. 4x times x squared gives me 4x cubed. 4x times negative 20x will give me minus 80x squared. Then I'm going to have plus 4x times 100 is 400x minus 500 equal to 0. And I should note that all the coefficients and the constant term have a common factor of 4, so I can divide the whole thing by 4. We'll take out the common factor, which will give me x cubed minus 20x squared plus 100x minus 125. 4 goes into 500, 125 times. Now, this is where it's important that we need to factorise this to find 3 values of x, because we've got a cubic function. And I know from before in part C that x minus 5 was a linear factor. So that allows me to then do the division of this new cubic term. I'm going to divide it all by x minus 5. Now, just for shorthand, I'll use a synthetic method. I'll put my 5 out the front. I'm going to put all the coefficients of this cubic function in the top box, I'll have 1, negative 20, 100, and negative 125. Set up my boxes. I'll put my 0 in. This is just a shorter way of doing the long division. If you're using a CAS calculator, you could just set in that whole equation at the top here and solve for 0, and it'll give you 3 values. If you're doing this by hand, it takes a little bit longer, but what we have to do is first is find what quadratic function times by x minus 5 will give us this cubic function. So using the synthetic or box method, 1 plus 0 gives me 1, 5 times 1 is 5, negative 20 plus 5 gives me negative 15, 5 times negative 15 will give me negative 75, which will give me positive 25 here, and 5 times 25 gives me 125, gives me no remainder, which we were expecting because we know x minus 5 was a factor. So using these new values, these are the coefficients of my quadratic term. I can say that x minus 5 multiplied by x squared minus 15x plus 25 equal to 0, and now I have to solve for x. I know that one value will be 5, and the other two values I can use my quadratic formula with a being 1, b being negative 15, and c being 25. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, which would be positive 15 plus or minus square root of 15 squared would be 175 minus 4 times 1 times 25 minus 100, all divided by 2. So that would be 15 plus or minus the square root of 75, which would be 5 root 5 all over 2. So there's 2 more answers, but the first thing we should check is, do they satisfy the practical application of this question? If I go up the top here, I notice that my length is 20 minus 2x. If that x value was 10, then that'd come into the halfway there. So x must be between 0 and 10. So if I look at my 2 possible answers, I note that x must be between 0 and 10. So therefore, we have to reject one of these values. So x can be 5. That fits between 5 and 10. 15 plus or minus 5 root 5 divided by 2. If I don't have a calculator on me, I want to try and estimate what that value is to find out, is it actually inside 0 to 10? Well, I know that root 5 is going to be 2 point something, just a little bit bigger than 2. So that's roughly, if it was a plus 15 plus 10, be 25 divided by 2, it's going to be much bigger than 10. So we're going to reject 15 plus, but 15 minus 10 is going to be positive 5 divided by 2, will fit side. So we'll have 15 minus 5 root 5 all divided by 2 is our other possible answer. And they're both the x values that will give you a volume of 500.